In this video, let's have some exercise on tree structure. Let's create a point using XYZ, construct point. And now let's create a series of numbers. By default, it gives us numbers from 0 to 9, a total count of 10. Let's change that to 5. So 0, 1, 2, 3, 4. If I plug in the series numbers to x input of the points, I'll get 5 points along x-axis. So that's going to be 0, 1, 2, 3, 4. Those are the x values. And y coordinates will be 0. So that's why we have 5 points laid out along the x-axis. If we input these numbers into y input, then we'll get diagonal points, which is 0, 0, 1, 1, 2, 2, 3, 3, and 4, 4. This is because when you have the same number of values going into x and y, it's going to match 1 to 1. So 0, 0, 1, 1, and things like that. So what if we graphed one of the inputs, for example, x, then what happens is we have a 2D array of points. So to further investigate how this happens, we're going to use a data placeholder and plug in this into x and cancel the graph. And we can graph on this battery. So what you can see is the data structure coming into y and x is different. So for x, the data structure is a tree. So if we use a param viewer component to look at it, you can see that we have 5 branches, and each branch we have one component. On the other hand, the input for y, we have one branch, and there are 5 values. So when we put the two different data structure into the inputs of the point, each of the value here will match with all 5 of them. So basically, the first value is 0. And you can see that I have 5 different branches here. So under each branch, I have one value. On the other hand, I have only one branch. Under one branch, I have 4 values. So when you match the two of them, this inside this one branch, this 0 will match up with all of the values here. So it's equivalent to 0, 0, 0, 1, 0, 2, 0, 3, and 0, 4. For the next branch, we have a 1, and then 1 will match with all of them. So 1, 0, 1, 1, 1, 2, and so on. That's why we have an array of points. What if we do the same thing for y value and graphed y? What would happen? Take a pause and then try to guess what would happen. Now it's time to reveal the answer. If you graph that, it's coming back to that single line, sloped line, because now the data structure, they are exactly the same. So the first branch, you have a 0. Y value, you have a 0. So 0 is matching with 0. 1 is matching with 1. 2 is matching with 2, and so on. So you have 5 points. So either way, if you cancel one of the graphs, it's going to be that 2D array. Doesn't matter it's X or Y. But if both of them are in list structure or tree structure, and you have one single profile, sloped points. Let's try another example. So if I make a series of points, X, Y, Z, so construct point, and then copy and paste this point here. And if I create a series of numbers from 0 to 9 and use that x as the x value, and for y value, I'll use different values. For the point here, the upper component, use 2. So you can see that the y values for those points are 2, and for the lower one is 0. Now, if I create lines using these two sets of points, plugging into A and B, as you can expect, I can create 10 lines matching all of the points. If I graphed one of the input, what would happen? So please pause the video and take a guess. So the answer is for each of the points at the bottom will match all of the points on the top. And if you graph the other input, what would happen? So as you might guess, it's going back to that 10 lines because data structure of these two are exactly the same, all in tree structure. Under each branch, there's only one input, as you can see here, and as you can see here. And if you undo the graph on either one of those, you'll see that it's going to become another tree structure matching with a list structure. So each of the index will match with all of the others.